So for this vision system, as you see here, I'm going to have me running through the system as it's going on because it takes quite a while to run through it all. Um, so for the overview, basically, the object is to detect triangles, squares, and circles. So there's 40 of them, and then some of them have black surfaces that are reflective, some of them are dull, some of them are black, and then some of them are white. So this kind of gives a nice wider range of different colors to try to pick up with the same settings. So if we're looking at the rigging here, so we got the outer box. The outer shroud basically allows to prevent shadowing or ambient lighting from hitting the system. So like somebody walking by, or let's say there's a door opening, or in the shop the light turns on or off. So this kind of isolates the situation, which then so with that said, you need a light. So got the ring light there to give even lighting and not create shadowing. And then the OpenMv is connected to the 8020. And so with that, this allows adjustability in the up and down direction, and then depending on the mounts, it allows for maneuverability with the OpenMv to get it situated. And this is all directly connected to the green, that green printed platform there. So as you can see, the user is able to place it in the same spot every time because there's little ridges to grab it. So you place it there, you wait for the LED to turn on, and then you move it and place the next one. So as you can see there, the LEDs are turning on and off back there, and this allows for different tell you what the user what's happening. And so with the setup, it gives the user 3.5 seconds to remove and place the next object, which is a good amount of time. You're not working too fast or too slow. But this is also changeable. And then as you can see there, the button to the right hand side allows you to, once you're done, to save the information into a file. So as it's going through, it's recording the pictures, but also when you want to save the count, it saves it to the file. And this allows to make sure that you're not like duplicating information and stuff when you're for like, let's say you're collecting for IoT. And as you can see down in the lower right hand corner, or the left hand corner, is the values. So it prints out, square detected. I know it's a little hard to read, or it prints out circle, and then it gives all the values that it's running through. And then so also it prints out how many have gone through the system, so where it says triangles, circles, and squares. And so when the system's done, you'll notice as I print the button, as I'm finishing up here, as I print the button, you'll see it kind of go by quick, and that records that the JSON file has been recorded, or as you can see, all 3 lights light up as I press the button. And so with that, I'm able to go into the OpenMv here, and just trying to get it all situated here. So once I pull it up though, I'll be able to look at the JSON file and the pictures that were taken as I was working through the system. So click here, open up the JSON file. As you can see here, triangle, circle, square, and there's 40 parts, and that all adds up to 40, so that means that everything checks out on that end. And then now we will go over and scroll through the pictures that were taken. So if I go over to images, and then you can see over there in the thumbnail the pictures that were taken. This is before the image is processed to detect the shape. And then now we will go over to check out the code I've written and kind of go into different details of the project. So just a quick brief overview of the code. So for the code, got my libraries. This is the time and date for everything. So for the image, so when it saves the image, it can update the time and date and basically save it as a unique image. Area of interest isn't actually used in this, but if I want to just bound out the region and just only look at a particular area on the image, then I would use that again. For the pins, this is to set up the LEDs to give the user a visual, and then I also have a reset button, and this drops the JSON file into or drops one of the values into a JSON file, which I'll talk about a little more in a sec. Green threshold, So this is basically the background. So I don't know if you noticed in some of the pictures that you saw, but the background is actually green. So this will basically take everything that's green, turn it to white, and then, everything that's green turns to white, and then everything else that isn't that fall in that range will turn to black. And then, so shapes, this basically saves each object that goes through the sensor, saves it as a circle, square, or triangle. With the sensors, I bring it in as RGB because as we talked about in the green threshold, I need to see the color. So RGB helps with this process instead of using grayscale, but then I'll turn it back into binary. So go into the while true loop. So sensor takes the snapshot, does a lens correction because of the distortion of the lens. And then, so this is binary, so back up here where the green threshold is where this comes into play. So turns the green into white and then the black into, or everything else into black. So this helps to deal with white, and because the shape's white and black, so it helps deal with that white and black by using a green background. And then updates the time and date again to give unique value for each time it saves the image. This is the button press. So when button presses, it saves it to a JSON file and then prints out, tells you that it's saved. All three LEDs turn on to let the user know that the button's been pressed. And then if we go down here for blob detection, blob detection threshold, so it's not picking up, the little edges. I think in this one you see like little edges up in the top corners and stuff, so it won't pick up that. We are using density values, pixel values, and area values for this particular program. So with density, so like a circle has around a 0.7. Let's easier one, square, since it's pretty much picking up the whole area, it's 0.9%, so, or 90% of it's black, and then the 10% is white. So that's kind of how the thresholds work. And then, so basically in this area, so we're detecting a square right now, so the density value is between, or above that value, the 0.76, and then basically it has to meet in between these area thresholds and the pixel thresholds, and with that, it gives a little bit of leeway, so you can, so if the circle's a little bigger or a little smaller, because in this circumstances, they're not all the same exact shape, so this gives a little bit more leeway. So in the kind of in the bulk of the code, so it turns the LED on, lets the user know, saves a snapshot of the image, and it's going to save it as the RGB style image and not the black and white binary image. And then and then it delays it for 3.5 seconds. So this allows basically, once the image is placed, you can swipe it off and place the next image, so you kind of get a flow that's 3.5 seconds. This can be changed a little depending on if the operator wants to work faster or slower, or the company. So same idea with the triangle, it's just now the thresholds are different. So as you notice in the square above, it's 0.7 or 6.7 for the density threshold, and this is between 0.58 and 0.4. And then area and pixel densities are a little same. Everything in the middle is the same as up above. And then the last is a circle, so density values change, area values and pixel values change, but everything else for the most part is about the same, except like for new name it saves it as circle